Next, let's talk about an overview of a subfield called information retrieval. Okay, as the name says, information retrieval is retrieving information. So there must be a large pool of data, and you want to find relevant information. Okay, now what is relevant? So relevance is a very subjective notion, but in an ideal scenario, given a particular user and a large pool of data, oftentimes called as a corpus, technically, what you want to figure out is something that is relevant and really important for this person. Okay, but in general, it is very difficult to personalize stuff. Although there are new techniques for personalization, it's difficult to personalize, and therefore relevance is usually considered as a notion that something which is relevant for a majority of people. Okay, so for example, if somebody is searching for Sachin Tendulkar, do you show the Master Blasters page at the top, right? Or there might be Sachin Tendulkar, somebody named Sachin Tendulkar, but a good surgeon, but most search engines would still rank Sachin Tendulkar at the top, and that's because search engines assume that the notion of relevance is the notion that captures relevance for a lot of people. Okay, and therefore they rank Sachin Tendulkar at the top, right? The Master Blaster. Okay, so typical information retrieval engine follows this architecture. There are a whole bunch of documents from which you want to retrieve information. Okay, and these documents have to be indexed. Okay, why do they need to be indexed? Because when somebody queries for a particular kind of information from these documents, one has to go over these documents very quickly and come up with an answer within a few seconds. Okay, for example, if you search for flight from Hyderabad to Bangalore on Google, you don't want the answer to come up after a minute or an hour and so on, right? You want the answer in a sub-second level, right? And that is why it is very important to index these documents nicely. Now, what is an index? An index is a compressed version of the same document, same information which is contained in these documents, but one in a compressed form, and second such that it is very fast to search on top of it. Okay, that's an index. Now, when a user query comes in, flight from Hyderabad to Bangalore, this index is queried and a few important documents are obtained which match this particular query. Okay, and then there is a further ranking module. So basically this ranking model, the module called ranking model, it tries to rank among these top few which have been retrieved, which actually contain all those words, flight from Hyderabad to and Bangalore, which of them are more important ones. Okay, for example, somebody's blog where they have described how their recent experience with Air India was screwed up, how the flight got delayed significantly, how they had huge number of jerks on the flight, and how they were manhandled in some way. Right? You don't want that blog to turn up at the top when somebody is searching for flight from Hyderabad to Bangalore. At the top, what you want is a page from makemytrip.com, or a page from Go Indigo, or a page from Jet Airways, right? That's the job of this ranking module. Okay, so it basically ranks those result pages and shows them at the top. And of course, this has to be learned. So how do you do this ranking? Has to be learned using some training data, and that is where components of machine learning also play a role. Okay, so this is how typical IR systems work. Now, or information retrieval systems work. Information retrieval is not just about web search, it's also about other use cases like desktop search. When you search for a particular file on your desktop, again, among all the file names, one has to figure out those names that match what you are searching for. You can also use those for library search. In fact, information retrieval is again a very old field. In 1960s, 1970s, information retrieval existed, and that was used for library search. It was used for patent search. Given a large collection of patents, how do you figure out which of those patents contain the query words that you're looking for? Okay, that's all information retrieval. Now, going a little deeper, so as to really get these documents, one has to somehow crawl them. Okay, so if it is Google, a general web search engine, then it has to crawl the documents all across the web. Okay, and this is an architecture of a typical crawler. We will not go into details for now, but a crawler, the job is get me all relevant documents. If it is Indeed.com, which is a jobs website, a jobs aggregator website, its job, a crawler there would want to just crawl job description pages, not general pages, but just job description pages. If it is Housing.com, they would want to crawl real estate listings. Right? If it is carvale.com, they would want to crawl in general anything about cars. Right? So crawling is an important component in any information retrieval system where you first want to get the content. It is this part in our bigger picture. Right? After you've gotten the stuff, you want to index. A popular way of indexing these documents is called inverted index. Inverted index are actually very similar to the indexes that you have seen at the back of a book, where there is a concept or a topic or a word, and you will find which pages do those words occur in. Okay? So in our case, or in case of information retrieval, there will be all these words. And for each of those words, what you would have is a set of document IDs where these words appear in. It turns out that this way of capturing the words and indexing them is a very, very efficient way of using them to really answer user queries very quickly. Okay? So lastly, there is this ranking model piece. So ranking involves a very, very rigorous process. So besides making sure that many of the query words are going to be present in these documents which are returned, you also want to really rank authoritative websites at the top. For example, you want to really rank Make My Trip at the top when somebody is searching for flights, rather than ranking somebody's blog page at the top, right? And fortunately, there's an algorithm called PageRank, which Google founders actually invented way back in 1998, but which still holds very good in terms of ranking web pages, authoritative ones at the top. Okay? So, and then there is a whole bunch of formulas which go into this ranking model. This involves something called as TF-IDF scoring, something called as cosine similarity computations, and so on. Okay? We'll go into the details of these things whenever we talk about information retrieval in detail. But for now, this is what contributes the information retrieval piece. Finally, whatever system you build, you want to measure how good it is doing. In general, classifiers are evaluated based on their accuracy. But how would you evaluate a search engine? How good a search engine is? Of course, a search engine is good if it basically shows relevant documents for your query and at the top. Right? You don't want relevant documents at the bottom. You really want at the top. Nobody really visits the second page, third page, fourth page on Google search results. People really look at the first page only. And that too, really people concentrate at the top. So they really want their result as the topmost result, right? NDCG is a metric which people use so as to evaluate these IR systems and figure out how accurate they are in terms of the NDCG metric. Okay, so that's a short description of this field called information retrieval.